Our computers consist of transistors, which are the primary block of a CPU. It creates the binary zeros and ones, also known as bits, that the computer uses to communicate and deal with Boolean logic. Now, our world is changing very fast. We are encountering complex problems regularly. To solve that, we need high computational power. In other words, more transistors in compact space. Moore's law states that the number of transistors we can build in computers doubles every 2 years. That means at a stage we cannot build even a smaller transistor, since the size of a transistor cannot possibly be smaller than the distance between atoms in crystal. And it is predicted that transistors will stop shrinking after 2021. So the idea of quantum computing arrived in 1980s. Quantum computing is the exploration of collective properties of quantum states such as superposition and entanglement to perform computation. It is a modern way of computing that is based on the science of quantum mechanics and its unbelievable phenomena. It is a beautiful combination of physics, mathematics, computer science, and information theory. It provides high computational power, less energy consumption, and exponential speed over classical computers by controlling the behavior of small particles like atoms, electrons, photons, and etc. In classical computers, we store data in bits, which store either 1 or 0. In quantum computers, the subatomic particles like atoms, electrons, photons, and ions are used as quantum bits, also known as qubits, along with their information of spin and states. A qubit can store 0 and 1 simultaneously. The value of a qubit is a vector with length 1 on a plane. A qubit is written as follows, while it has 2 components, and 2 qubit is a vector of 4 components, and this increases exponentially. For n qubits, it is the vector with 2 power n components. Thus, quantum computers can create vast multidimensional space in which we can present large problems that classical computers cannot do. That's why quantum computers can do some tasks very quickly. Not all, by the way. For example, let's say we need to find a permutation of 10 digits. Classical computers will check those 10 factorial or over 3.6 million cases one by one. Let's assume each check takes 1 second. So in the worst case, classical computers will take around 42 days. In contrast, using Grover search, we can find the combination by roughly checking square root of times cases than actual. In this case, that would be around 1904. And within 30 minutes, that will be cracked. And that's what makes quantum computers do certain tasks super fast.